Alright, my neighbor called me to check his TV, an old CRT TV. First, let's have a look at the symptom. TV chu hin on in lang a screen ang thiên tin hin that by to. Yes, there we have just a horizontal line, so we don't have full display here. So we need to troubleshoot this TV, see if we can fix it. Alright, we have the top view of the main board here. This is pretty old circuit board. We have seen horizontal line displayed on the screen that tells me that the horizontal section is still working while the vertical section had gone bad, simply because we have no vertical line on the screen. This probably is due to defective vertical IC. I'll show you the vertical IC. That is the vertical IC attached here against this heatsink. Because this for most of the time used to be the culprit regarding vertical faults. We have a vertical fault here, or it could be that there is no signal to turn it on because the vertical IC can just stay on without a signal even if it's not defective, or it could be some other components failure such as resistors, regulators, etc. So we will check some important volts and readings and see if we can fix it. Alright, this is the bottom view of the board where probings and testings will be done. I'll show you how voltage from the start get processed all along the way and distributed appropriately. First, I'll set my meter to AC to check the AC inlet. Here we have around 224 volts AC, which is nominal. Again, I'll set my meter to DC mode to check the DC output. Here we have 304 volts DC. The voltage increase as there is the full bridge rectifier circuit and the filter cap there. Actually, the signal has been totally converted from AC alternating current to DC direct current. Anyway, the input powers are totally fine. Moving on, I will now check the power distribution within the power supply section. This is the power supply section. What it does is it processes the input signals and distributes it to different sections within the circuit, namely the sound, the vertical and the horizontal sections. The sound section is pretty much obvious that it is for the sound. The others are the vertical and the horizontal sections. We know that TV screens are two-dimensional figure, vertical and horizontal, so it requires the vertical function and the horizontal function the same way as the x and y functions on a two-dimensional graph. Of course, this is not the explanation to how TV works, but this, I believe, is the basic concept. Anyway, moving on. Put my ground probe there. First, we have around 108 volts to the horizontal section, which is normal. Again, we have 24 volts to the vertical section, which is also normal. Take my word. Again, we have 11 volts. This is going to be some sort of signal voltage. We might come back here because this is different. Lastly, I have here 15 volts to the sound section, which is also pretty much normal. So that concludes that all the power supply sections are working great. The individual signals are fine and normal. And so for my next step, since we have vertical faults, however, there is normal power for the vertical section, which is the 24 volts DC. I'll check whether the signal really reaches the vertical IC or not. Here, whether this 24 volts really gets into the vertical IC. Alright, I'll zoom in a little bit so that you can see it. This is the spot where the vertical IC is located, and now we will check whether if this 24 volts really get here. So this vertical IC has 7 terminals, 1 to 7. You see the second and the sixth terminal where it says VCC and out VCC. The VCC is where the 24 volts should enter and the out VCC is where it should come out from. So we'll check whether if this is met or not. This is a 24 volt line. I'll follow the path, reach here, and there is a jumper cable and right to VCC pin, and it does. Now we'll check how many volts comes out of the out VCC pin. We have 23.5 volts. The voltage decreases as there is load inside the IC. Okay, since the power supply to the vertical section is normal and indeed the vertical IC is receiving enough power, yet we still have vertical faults. This could be due to defective vertical IC, so this might be a time I replace it. But before I replace the vertical IC, I will check the voltage regulator within the vertical circuits. Basically, what regulators does is they regulates their output. For example, a 5-volt regulator will give out 5 volt as its output no matter how much high voltage you supply to it. Of course, it will blow up if you overpowered. Regulators have their limits up to what levels volts they can handle. So the probable case here is that the regulator has been damaged, or if not, it could be some other components failure. That's an obvious case. So this is the regulator that I talk about. It is a 5 volt regulator, meaning it will give out constant and regulated 5 volt as its output, and no matter how much higher voltage than a 5 volt is supplied to it, considering its limit. Again, it will send that 5 volt signals to the main IC processor. That's the main IC processor, and as soon as the main IC processor receives the signal being sent by the regulator, it's like the vertical IC is asking the main IC processor through the regulator, hey main IC, I want to turn on, please help me. So at that point, the main IC processor will turn the vertical IC on. So our conclusion here is that chain of connection or communication among the components might have been interrupted. So let's check if that's the culprit. This is the output pin of the regulator where it should read 5 volts. So I want to probe the spot and see. Oh, just 1.4 volt instead of 5 volt. Maybe the regulator had been damaged. But before I remove and replace it, I'll check the input voltage, because if there is no input, there cannot be output. This is the input terminal where voltage higher than 5 volt must present. So I'll probe and check again. Here it goes. Out. Out. Oops, we don't have enough input voltage, just around 1 volt. This cannot happen because 1 volt cannot be regulated to 5 volt. There is no such thing as free energy. Maybe there is broken line within this section. So I'll follow the path. Here we go. There's a resistor across and another resistor across. Basically, these two resistors are connected in series. Here we have around 11 volts. But out of the resistors we have, well, almost no output. Maybe the resistor has been damaged. Anyway, let's check its value. So this is the resistor in focus, so I want to read it. We have yellow, violet, gold, gold. That's when interpreted is yellow equals 4 as first significant value, violet equals 7 as second significant value, gold as multiplier equals 0.1. That means 47 times 0.1 equals 4.7 ohms. And the last code is the uncertainty value. Here gold, which means there is an error of 5% from the stated value, that is 4.7 ohms. Because nothing is 100% efficient. You have to allow the uncertainty in every measurement you make, because measurements without uncertainties are completely meaningless. However, a 4.7 ohm resistor will never give out just around 1 or 2 volts if it is connected with 11 volt supply line. Anyway, this 11 volts comes from here, the signal voltage that I talked about. No argument, this resistor needs to be replaced. Okay, I have replaced the resistor with a new one. So let's check some volts reading here. It was 11 volts, but now it drops down to 10 volts because the resistor is drawing currents and there's voltage drop now. So it is going along this path and stop right there. And there's a 1 jumper cable right here. And then it will jump to right here. So and it will continue going through that trace and it will reach the input of the resistor that I have replaced. Now we get 8 volts out from the first resistor instead of the 1.3 volts before, and this 8 volts is going to the second resistors and we have 6.4 out, and this 6.4 volts out is directly going into the input pins of the regulators, and it will be regulated down to constant and regulated 5 volts. Now 5 volts is available now. So let's check if this 5 volts really gets to the main IC here. Let's follow the path here. Okay, we have 5 volts there, and there's a branch here again, so let's follow again. Alright, we have both the 5 volt available to the main IC. These 5 volts is necessary for the main IC processor to turn the vertical IC on. I think the TV must be, if it works, must be working now.